Okay, so now we have the 10 projects, and how many programmers will be needed in each of the 10 years for each of the projects. Okay, now here is the 0, 1 changing cells, which will tell us whether we're going to do a given project or not. Okay, so if you do a sum product of whether we're going to do a project or not with each column, that will tell us how many programmers we will need in a given year. Okay, like for example, if we are going to do project 1 and project 8, then we will need 75 programmers. If we are going to do only project 1 and not project 8, then we will need 37 only. So if you do a sum product of that and each column, that will give us the number of programmers needed, which will be in row 47. Okay, so now we have to set up how many programmers will actually be available. Okay, we start with 100. Initial number of programmers is 100. And we have number of programmers hired here. So that plus that, 40 C40 plus C41 will give you the number of, I'm sorry, here C40 plus C41 here, this cell will give you the number of programmers available. Okay, that plus that, so that will be available, and that should be greater than or equal to the programmers we require. Now this is for year 1. Now you see that there is a percentage of people who will quit going from one year to the next. So the next year, the initial number of programmers will be the number of programmers we had in first year. Okay, so that's the number of people who would have quit. So this minus 10% of that. So in other words, it will be that times 1 minus 10%. So that will be the initial programmers there, and that plus number of programmers we hire will give us the number of programmers we'll actually have. Okay. Now here we need to set up one more row for whether we're going to hire or not, because there is a cost involved for training. So if we are hiring anybody, then there will be a fixed cost of training. If you're not going to hire anybody at all, then we will not have that cost. And that cost is, it doesn't matter how many people we hire. If we hire 1 or 100, it doesn't matter, we will have a training cost. We will not have a training cost only if we don't hire anybody at all, and that's why we need this row, which is do any hiring. So this will be a binary row, and so you multiply that number by the logical upper bound, which is the maximum hires per year. So we have a limit, you can only hire 80 people. So that cell times that will give you the logical upper bound. So if we don't hire anybody at all, then that will be 0 times 80. So you will have 0 in the number of programmers hired row. Otherwise, you will be allowed to hire up to 80 people. So this times that will be your logical upper bound. Okay, so let's get that set up. So the logical upper bound programmers available will be initial number of programmers plus number hired, and then the initial for year 2 onwards will be the number of programmers we have, which is in row 45, times 1 minus that percentage. So that will be the number of programmers, initial number of programmers for year 2 onwards up to year 10. Okay. and then these would come from, whether we're going to do a project or not, okay, times revenue from the project. Revenue from the project is here, so we do a sum product of that, and that will give you the revenue. And then training cost will be in how many years we're going to be training. So if you sum this row, they'll tell us how many years we will have a hire. That times the training cost. So sum of this times the training cost will give you the cost of training. Cost of salaries will be how many programmers are available in each of the 10 years. And you add them all up, and then you multiply by the salary. Programmer salary is $50,000. These are in thousands, so $50,000. So times 50. Sum of that times 50 will give you the cost of salaries. So then revenue minus the two costs will give you the net profit. So net profit is your changing cell, and then we have these two constraints, the logical upper bound and the number of programmers needed, plus the two binary constraints. Okay. And then the number hired, you can make that integer as well, the row 41. You need to make that integer. Okay. The very first one is just the initial number of programmers given here in cell C18. Okay. After that, for year 2 onwards, okay, so since there is going to be a certain percentage of programmers who will quit, okay, so you need to take the number of programmers available, okay, number of programmers available in a given year, and you have to subtract from that number the percentage of people who will be quitting. So this minus 10% of that, which is same as saying this cell times 1 minus the percentage who will quit. So that would be so 1 minus percent who will quit times C45. So that will give you the initial number of programmers for the second year, and now you can copy this across. Now that plus number of new hires will give you the number of programmers available for year 2. Okay, logical upper bound is, okay, you are allowed to hire a maximum of 80. Okay, and here in this row we have a binary changing cell, okay, either 0 or 1, which would indicate whether we're going to do any hiring at all or not. So a 0 here means we're not going to do any hiring at all. If you have a 1, that means we're going to hire some people. Okay, so if you take this cell and multiply by that one, so that one should be absolute reference, remember. Okay, then that's what you should have for the logical upper bound. The maximum hires times this cell. So that way, if this is 0, so 0 times 80, your upper bound will be 0. So you will not, since you're not going to hire anybody at all according to this row, your number of hires will be forced to 0 because it has to be less than or equal to 0 then. On the other hand, if you have a 1, then this value will be 1 times 80, and then cell D41 will be allowed all the way up to 80. So the logical upper bound is C19, the maximum hires allowed, that should be absolute referenced, times whether we're going to hire or not, C38. And then you can copy that across to the rest of the columns. Okay. Here, programmers available is initial number of programmers plus how many we're going to hire. So we start the year with that many. This is the number of new hires. So this plus that will give you the programmers available. And same way for the rest of the years. Okay. Now programmers required will be based on which projects we're going to do. So for each of these projects 1 through 10, these are the number of programmers that we will need in each year 1, year 2, year 3 and so on. So if you do a sum product of whether we're going to do the project or not with that column, okay, so that will give you a number of programmers required. So this should be absolute referenced, this is free, then you copy that across, that will give you the number of programmers required.